Hello everyone and welcome to mathMinutes. In this video, we're going to be exploring simultaneous equations, and in particular, the substitution method of solving them. To start, let's define what simultaneous equations are. Simultaneous equations are a set of two or more equations that share common variables. For example, consider these two equations: 2x plus y equals 7, x minus y equals 2. These are simultaneous equations because they both have to be true at the same time for the same values of x and y, and our goal is to find these values. Simultaneous equations are an essential concept in algebra, and understanding how to solve them can be crucial in many real-world situations. So on that note, let's dive in. There are different methods for solving simultaneous equations. The three common methods are: number 1, the substitution method; number 2, the elimination method; and 3, the graphical method. In this video, we're going to focus on the substitution method. Let's start by understanding what the substitution method is. There are broadly 4 steps that we can break this into. Firstly, we rearrange one of the equations so that we have one of the variables written in terms of the other. Then, we substitute the expression of this variable into the other equation. This would leave us with an equation with only one variable. Next, we would be able to simplify this equation and solve for that variable. And finally, we are able to substitute the value of the variable we have just worked out into one of the original equations, thereby finding the value of the other variable. Let's take an example to illustrate this process. Let's solve the simultaneous equations from earlier. 2x plus y equals 7 and x minus y equals 2. The first step is to rearrange and isolate one variable in one of the equations. In this case, let's isolate y in the second equation. We have x minus y equals 2. If we add y to both sides, we're left with x equals 2 plus y, and if we now subtract 2 from both sides, we're left with x minus 2 equals y. Now we can proceed to the second step. We substitute this expression for y into the first equation. This gives us 2x plus x minus 2 equals 7. Step 3 is to simplify and solve for x. Collecting like terms, we have 3x minus 2 equals 7, and rearranging and simplifying, we find that x equals 3. Now that we know x, for the final step, we can substitute back into either of the original equations to find y. Let's use the second equation, which we've already rearranged for y. Y equals x minus 2. Substituting x equals 3 gives us y equals 3 minus 2, which equals 1. So the solution for our simultaneous equations is x equals 3 and y equals 1. We can check our answer using the values we have worked out in either of the original equations. Let's use equation 1. 2x plus y equals 2 times 3 plus 1, which equals 6, plus 1, which equals 7. So our solution is correct. Let's try another example. Let's solve the set of equations. 3x plus 7y equals 34 and 2x minus 4y equals 14. We'll use equation 2 and we'll rearrange so that we have x isolated on its own. Here we have x equals 7 plus 2y. Step 2. We substitute this expression for x into equation 1. Expanding the brackets gives 21 plus 6y plus 7y equals 34. And if we simplify, we find that y equals 1. Now with the value we have of y, let's substitute into the expression of x to find that x equals 9. So there we have it. Our solution to the simultaneous equations is x equals 9, y equals 1. We can do a quick check to see if this is correct. If we use the first equation, we can see that 3x plus 7y is equal to 3 times 9 plus 7 times 1 equals 27 plus 7, which is 34. Let's do one final example. Let's work on an example with more context. We're given the question: Sarah buys 6 cupcakes and 3 brownies for £9.60. Benny buys 2 cupcakes and 5 brownies for £6.80. What is the price of 1 cupcake and what is the price of 1 brownie? In this example, we are not explicitly given a set of simultaneous equations. Instead, we have to choose variables and write out the questions as 2 simultaneous equations. So, let's choose the letter C to represent cupcakes and the letter B to represent brownies. We can now represent Sarah's purchase as the equation 6C plus 3B equals £9.60. And we can represent Benny's purchase as the equation 2C plus 5B equals £6.80. Now, we have our pair of simultaneous equations, and we can use the substitution method we've learned to find out the price of one cupcake and the price of one brownie. Let's take the first equation and rearrange so that we have B on its own. We have 6C plus 3B equals 9.60. If we subtract 6C from both sides, we have 3B equals 9.60 minus 6C. And dividing both sides by 3 gives us B equals 3.20 minus 2C. Substituting this expression for B into the second equation, we have, and if we expand the bracket and collect like terms, we're left with 16 minus 8C is equal to 6.80. If we go through the steps, rearranging and simplifying, we're left with C equals 1.15. Next, we use this value and substitute into the expression for B to find that B equals 0.90. As before, let's check our values are correct. We'll use the first equation this time, and we can see that substituting both values yields the correct answer. So there we have it. The price of one cupcake is £1.15 and the price of one brownie is 90p. The substitution method is a very useful method for solving simultaneous equations, especially when one of the variables can be easily isolated in one of the equations. It may seem a bit confusing at first, but with practice you will get the hang of it. Thanks for watching, and be sure to subscribe to our channel for more math videos.